From looking at the previous slide, you probably know that today we will be having a rather serious discussion. Today we will be investigating why the chemical byproducts of large-scale chemical reactions need to be properly disposed of in order to have a lesser negative impact upon the environment. And anyways, as we have all previously studied living organisms in the past, we should all know by now that on a day-to-day basis, organisms have interactions with the environment on numerous occasions. Us as humans, we have numerous occasions when we interact with the environment because of our daily activities, and also because of our reliance on nature's resources. And because we take these resources and refine them into our own products, we put waste materials back into the environment. However, so to speak, some of these wastes are beneficial to the environment, such as manure. However, most of these wastes, such as chemical byproducts, all have negative impacts upon the environment. And before we begin, we need to attain an understanding of what a large-scale chemical reactions are and what chemical byproducts are. Now let us begin.
So what exactly are large-scale chemical reactions? It's obvious that the term relates to the mass chemical industry worldwide and relates to the production of chemicals by major companies and plants. So in summation, a large-scale chemical reaction is a chemical process conducted by companies in which raw materials are refined into final products or compounds. And so what are chemical byproducts? A chemical byproduct is an incidental product deriving from a manufacturing process, either chemical or biochemical, and is basically the product that is not primarily desired to be produced in the reaction. However, so to speak, it can still be useful and marketable, or it can be simply considered as waste. And the wastes of these primary industries all have long direct impacts on the environment and living organisms that live in them. Besides this, these hazardous wastes can also cause harm to human health, and hazardous waste may consist of toxic chemicals, some being carcinogens, which are known to cause cancer in organisms exposed to them. For example, radioactive waste from nuclear fuel plants contain carcinogens. Corrosive waste, on the other hand, can cause burns and cause chemical damage to structures and alternate the pH of water and soil, affecting the growth potential of soil and the cleanliness of both soil and water, affecting wildlife and nature globally. Other reactive wastes are susceptible to violent chemical reactions such as explosions or fire. So as you can see, byproducts can be very dangerous. Mercury, lead, toxin, and nuclear reactive waste are commonly known dangerous byproducts. And the wastes of these primary industries all have long direct impacts on the environment and living organisms that live in them. Besides this, these hazardous wastes can also cause harm to human health, and hazardous waste may consist of toxic chemicals, some being carcinogens, which are known to cause cancer in organisms exposed to them. For example, radioactive waste from nuclear fuel plants contain carcinogens. Corrosive waste, on the other hand, can cause burns and cause chemical damage to structures and alternate the pH of water and soil, affecting the growth potential of soil and the cleanliness of both soil and water, affecting wildlife and nature globally. Other reactive wastes are susceptible to violent chemical reactions such as explosions or fire. So as you can see, byproducts can be very dangerous. Mercury, lead, toxin, and nuclear reactive waste are commonly known dangerous byproducts. Now it's time to turn our attention towards the production of fossil fuels. But first off, what exactly are fossil fuels? Fossil fuels are non-renewable resources formed in geological past from the remains of living organisms such as dead plants, animals, and microorganisms. The energy within these fossil fuels must be first extracted, and today burning is the easiest way to do so. Canadians burn large amounts of gasoline, oil, coal, and natural gas to power our cars, heat our homes, run our businesses, provide electricity, and deliver food to our tables. So as you can see, as a society, we have become very dependent on fossil fuels. Furthermore, fossil fuels themselves are composed of particles called hydrocarbons, meaning they contain both hydrogen and carbon. And this explains why when any fossil fuel burns, the main products produced are carbon dioxide and water vapor. The word equation below is the basic reaction that must occur for any hydrocarbon, including resources such as oil, coal, and natural gas, must undergo in order for a complete combustion reaction to occur. as we learned in Chapter 4. For today's discussion, that is the only basic information of hydrocarbons that you will be required to know, but we may learn more about hydrocarbons and the energy they contain in Chapter 13 and 14 if we reach them later this year. These combustion reactions listed below are obviously of commonly known fossil fuels in today's manufacturing industry. And as you can see, the first two reactions follow the basic hydrocarbon formula previously mentioned, while the coal one does not because, as mentioned before, fossil fuels already contain lots of carbon. The first reaction is a reaction of natural gas in which methane reacts with oxygen to produce carbon dioxide and water vapor. Now here's a fun fact for you guys. Natural gas power plants produce the least amount of pollutants compared to all other fossil fuel plants. Anyways, the second reaction is of gasoline in which octane reacts with oxygen to produce carbon dioxide and water vapor. And the final reaction is a reaction of coal in which the carbon reacts with oxygen to produce carbon dioxide. Before we continue, we will now be taking a few moments to see how drastically the levels of carbon dioxide emissions increased as of the beginning of the Industrial Revolution in 1708 to the year 2006. Please note that the gray areas of the map represent bodies of water, while the darker blacker areas of the map represent bodies of land, so please focus on those. Now let us begin. Because of the combustion reactions associated with the burning of fossil fuels such as those just mentioned, carbon dioxide has become one of the main byproducts of fossil fuel power plants. Carbon dioxide is a greenhouse gas pollutant and is linked to climate change and global warming, and as a greenhouse gas, it traps heat in the Earth's atmosphere, which causes temperatures on Earth to rise. As production of fossil fuels has increased over the years, the emissions of carbon dioxide have increased as well as previously seen, and now it is becoming a growing problem. Now here is an image of the carbon cycle, which explains the process in which carbon is cycled through the air, ground, plants, animals, and fossil fuels. And this chart explains more thoroughly how carbon dioxide emissions have increased and the impact it has had on the environment. Besides producing carbon dioxide emissions, the burning of fossil fuel also produces other byproducts such as sulfur dioxide, nitrogen oxide, and sulfur trioxide, which are all oxides which react with the water vapor in the air and contribute to environmental problems such as smog and acid rain. As you all should know, as previously studied in the chemistry textbook, acid rain occurs once the pH level of rainwater reaches levels below its normal of 5.6. However, some Canadian coal generating plants have developed special technologies that can reduce or almost eliminate these pollutants. Now here are three chemical equations that produce acid rain. Hydrogen sulfide, also known as sour gas, is another example of a byproduct produced because of the burning of fossil fuels. It is highly toxic, corrosive, and flammable, as shown in the images, as it often flares off oil wells. This combustion is also the producer of sulfur dioxide gas, which reacts with water vapor in the air. Oil companies are now making efforts to reduce this type of pollution, as it is harder to reduce because of the way it is formed. Finally, as you can see from this final image, and if you've been listening to anything we've been discussing today, is that in today's society there are plenty of air pollutants and byproducts from fossil fuels all in the atmosphere, which all have environmental impacts. And from studying and analyzing this image, it is possible to see that there are few natural processes in which these pollutants are removed from the atmosphere, while there are many more both natural and man-made processes which put these pollutants into the atmosphere. It is evident that even though there are few methods being used to dispose of these pollutants, much more needs to be done in order to balance this out. Now that we've finished with fossil fuel emissions, it's time for a brief overview of nuclear waste. And so what is nuclear energy? Nuclear energy is energy released by reactions within atomic nuclei in either nuclear fission or fusion. In these processes, nuclear power plants use uranium in order to convert heat into electrical energy. The reason as to why uranium is used for nuclear energy is because it has the largest atoms out of the 92 naturally occurring elements on Earth. meaning that uranium atoms are more likely to split up compared to any other atoms. And once neutrons come in contact with uranium atoms, the atoms split up and this releases heat energy. At the same time, once the uranium atoms split up, they also release more neutrons, which can then go on and split additional atoms, ensuring a chain of atom splitting. And this process is known as nuclear fission. And once all this heat is produced, it is then used to boil water into a steam, which spins a turbine and generator, which produces electrical energy, which can all be seen in this diagram. Unlike fossil fuels, the bonus of nuclear power plants is that they don't produce any fossil fuels and produce almost no smog or greenhouse gas emissions. However, the only downside is that they do produce dangerous nuclear waste, which must be handled very carefully and stored very carefully. And these nuclear wastes are dangerous compounds and highly radioactive as well. The appearance of the waste produced may appear as the original products, but its components are completely unstable. Waste from fission products fall apart and disintegrate and emit fragments in all directions. And it is the disintegrating wastes that are radioactive. This explains why nuclear waste must be isolated from the environment for an extended period of time in order for it to lower its level of radiation once its temperature decreases. Currently, the disposal method of radioactive waste is to enclose them in large cylinders composed of concrete and steel, which are placed in water-filled bays for an amount of 10 years in order to lower the temperature of the waste. However, unfortunately, these containers corrode from the inside out and are estimated to last only a few decades. Therefore, Canada's long-term plan for managing used nuclear fuel is to have a central contained isolation facility in deep rock formation. However, besides planning for this, scientists around the world must also look for innovative solutions to manage nuclear waste over long periods of time. In terms of pollution and nuclear waste, the only cause of this are the disposing of used fuel rods from nuclear reactors and the waste materials at the mines where uranium is produced. Canada is one of the top 5 producers of uranium in the world, accounting for 23% of global production, and all this mining has effects on the environment. In open cut mining, there are excessive volumes of barren rock and overburden waste consisting of other radioactive elements such as radium and radon in uranium ores. And the solid waste produced from these operations, called tailings, are composed of large amounts of radioactive ores and all contain radium in them. A hazard about this is that once radium ores are exposed to air, this will cause surface radioactivity on the ores and produce radon emissions, and so water is used to reduce this effect. Most of the tailings are then covered with soil in order to continue keeping them to decay. Furthermore, it is also a regularity for water from the mill to contain radium and other metals. This water is then simply evaporated and the metals and radioactive particles are moved into secure storage. It is very important to avoid any pollution in groundwater away from the ore body, or else this pollution will leak into the environment